Welcome to the latest presentation from Energyscape's lab. This presentation follows on from our previous one on space science education and the new paradigm upon us now in terms of science and technology that we need to get our heads around to support industries move off planet and out into space. So this one's called Future Ready Space Science Education, Modernising Curriculum to Meet Emerging Aerospace and Energy Industry Needs. Just a bit of background again, same as the previous presentation. So I'm the owner and founder of Energyscape's lab, and we focus on reverse engineering UAP technology. So we've done a lot of work in that space, which you can find on our ResearchGate page. I have a PhD in environmental and marine science, a graduate certificate in strategic studies, and a graduate diploma in education. I'm an accomplished science and technology author, so I have a science fiction novel series out based on the deep sea mining industry and a plot to roll out reverse engineered UAP technology in that mining industry to support the future of operations. So there's quite an extensive novel series. So if you want to have a look at that, you can have a look at that. It's called the Skimmer book series. And I've also got a autobiography out on my life as an experiencer of UAP and NHI, and a book coming out soon on the science of UAP over the last 80 years. And that's quite an in-depth analysis of evidence supporting UAP technology and its reverse engineering. So that's coming out soon. It's called Forbidden: A Science of Secrets. Experienced science educator, experienced research scientist. So I've been a research scientist most of my career in and around education and industry. Industry experience, so I've worked in fisheries and aquaculture, oil and gas, and a little bit of mining through the education sector as well. I'm a commissioned, or was a commissioned, naval officer with the Royal New Zealand Navy for a period of time, and my teaching experience spans across university, TAFE, and high school science. Just on the side here, we've got a clip from a UAP that was filmed and spotted over Perth not long ago, and Energyscape's got hold of the video and put it through our image analysis process and wrote a technical paper on it that's available on our ResearchGate page. So that was quite an interesting one as well, and looked at the technology behind it, or the application of that technology from reverse engineering. Now this presentation is based on the companion paper to this document here, this white paper, Bridging Classical Space Science Education with the New Paradigm. So we've done a presentation on that, which is on our Energyscape's ResearchGate page and also on our YouTube page, AD Morgan Media. So this is really a follow-up on that, and it's a discussion or a presentation on the companion guide that goes with that document. So just as an overview in here, we've got why this matters now. Why is space science so important at this particular moment? What are the key outcomes from the companion document and white paper on the paradigm shift in science that's upon us? What the companion document provides in this regard. And then we've got some conceptual frameworks around that, and curriculum by discipline area, and some lesson plan highlights from that companion document on this. And then we look at interdisciplinary curriculum modules that support the white paper document and an implementation strategy. And lastly, a call to action. And we've got this nice little visual over here showing an educator and some students in a little discussion session about the paradigm shift in science, which is all based around the rollout of Scalar propulsion technology and transmedium craft. So why this matters now? So Industry disruption is upon us. So irrespective of what's been going on in the private sector in terms of top secret technology and its development and use and its origin, what we have now spilling over into the public domain is a disruption of industry. And as an educator and within the education sector, we need to get our heads around this reasonably quickly, because this is only going to accelerate the pace at which this is happening. So aerospace and energy sectors are adopting technologies like field-based propulsion that require new integrative skills. Now this is particularly focused, well, the scientific shift is particularly focused on scalar fields and psionic interfaces that are redefining what space science encompasses. And our white paper and the previous presentation goes into a lot of detail on that. And Energyscapes Lab has written a couple of other technical papers on psionic interfaces and consciousness controlled technology if you're interested. So I won't go into that now. The other thing we need to look at, which the companion document outlines as it links to the white paper, is economic readiness. So students must be equipped for roles in fields that are only now emerging but will quickly become evident as a need for industry as we move off planet and out into space. And I would say in particular mining. I think a lot of it's going to focus around resource mining out there around the planet, and in terms of orbital technology and deep space technology and mining other planetary bodies. So another little video clip here from some of Energyscapes Lab work. Now there's a lot going on in the Pilbara in Western Australia with UAP, and that's one of our main focus areas, and we do a lot of work on videography and photometry up there, and other instrumentation. So this is a frame stacked clip of a major UAP event that's ongoing up there near one of the mine sites, and we've been analysing this and written a paper on it, showing some sort of structured craft going through some sort of energy coupling or power up. There's quite a bit to this video. There's actually other objects around it too, so we're still actually looking into this phenomena here and writing about it, studying it, analysing it, and looking at its application in reverse engineering technology. But that's a whole nother story. So key outcomes from the companion document. So what came about was that we need to bridge content that advances scientific literacy, so building continuity from classical frameworks in space science in particular to new scientific frontiers that we've pointed out. So to do that, we need to deploy deployment-ready curriculum scalable across schools, so it can be adapted and adjustable to the capacity and capability of the school that it's in. They need to have ready-to-use programs that can be adapted for STEM classes and elective subjects, because we're building on classical foundations here, and schools are busy enough as they are. So it's being able to provide a pathway with the flexibility to incorporate it at a scalable level within the capacity and capability of schools and their STEM focuses. We need to develop a talent pipeline connected to industry in this regard, so direct alignment with aerospace, energy and defence workforce needs, and that's quickly going to become apparent with this paradigm shift in science and technology that is starting to be rolled out globally now. And I'm well connected, or Energyscapes is, with companies that are going along the same lines as Energyscapes and trying to position themselves for what is happening now and what is going to happen. And that's quite evident online when you search now and look at keywords like deep tech or UAP innovation or reverse engineering, and that'll quickly become apparent, because they're going to become the service providers to major industries in energy production and resource extraction in particular. This is just another clip here from the Perth UAP analysis that we did, some exploded frame stacking here, looking at the mechanics of that object. So I won't go into that now. So what the companion document provides, so it's a visual comparison of classical versus emerging science. So it's framing changes without discarding the foundational models, and the focus of course is on space science education and how important that is now. So it's cross-disciplinary curriculum design. So we're looking at physics, chemistry, biology, earth science, and engineering, and how they're bridged to future concepts in terms of this paradigm shift in science and technology that's upon us now. So the companion document looks at interdisciplinary models. So we've got hands-on teaching materials for spectroscopy, psionics, and field interaction. And by field interaction, we're talking about energetic fields, scalar fields, and their interaction with the environment and objects, of course. Implementation roadmap. So the structured rollout for educators and systems leaders. So within the school environment, we're talking about integration and cross-fertilization of topic areas. So this new science, or this paradigm shift in new science and technology, requires a different way of thinking in terms of systems, which means teaching across subjects and not within subjects, because the science, this type of emergent science is not a siloed science. It's holistic in its approach and not reductionist. So a subject matter expert is going to struggle with the concept because it's so broad. So it requires quite an effort in terms of leadership and the likes of what Energyscapes is doing to educate the educators about how to go about doing this, basically. So the conceptual framework is in 3 phases. This is part 1 here of the conceptual framework. So we've got propulsion. So we're moving from rocketry or rocket science to scalar propulsion technology or resonance. So we're going from chemical thrust to field-based mobility. So that's what's coming out now from the private sector, from what they've been holding back for, I'd say, quite a considerable time, and probably for good reason. No need to go into that now, but the important thing is we're all moving together, supporting the rollout of this technology and what the resources are that are required for industry to adopt it alongside your more traditional chemical thrust based energy and technology. Part 2 is materials science. So we're moving from alloys to porphyrin biopolymers. So we're linking biology to next-gen composites, which are also linked to neural consciousness or psionic interface technology. So it's those essentially what you call them living skins or skin composite layers on frames, these Scalar craft frames. So we're looking at energy transfer as well. So we're going from electromagnetic to scalar coupling. So it's beyond electricity into field harmonics and coherence. Now that whole science is going to become quite a big field relatively quickly now. I would say that it's out in the public domain, and companies and industry are positioning themselves to support the resource sector, the energy sector, and the aerospace sector in adopting this technology alongside existing technologies. So in terms of curriculum by discipline, so part 2, we've got the physics. So we're going from Newtonian mechanics and evolving into inertial modulation. So in other words, inertia cancelling technology and gravity manipulation. For chemistry, so we're going from we're looking at molecular vibration and IR, and it's linked to energetic resonance. So it's going from the chemistry, the atom atomic structure and bonding, to looking at resonance, energetic resonance and vibrations. In other words, it's a bit like the Bose-Einstein condensate, where all atoms act as one atoms in a substrate. And we're looking at the production of scalar chiral phonons and energetic coupling with the lattice of space itself. So it's a different form of mobility which overcomes inertia and bypasses, I would say, by the way, the speed of light as well. So part 3, biology, we're looking at sensory systems tied to psionic control models. So that links back with this energetic resonance and chemistry as well of biopolymers. So we're looking at sensory systems that are thought controlled or consciousness controlled, linking back to that. So there's a lot of going into the, I suppose, the psychological aspects of biology as well in that regard. And then Earth and space science, we're looking at orbital logic and field mapping. So there's a lot of naturally occurring electromagnetic anomalies, and planetary bodies have their own magnetic fields and magnetic field lines. So it's looking at the orbital logic of these new craft in comparison to combustion-based technologies, and energetic field mapping in space, because this is all occurring in four-dimensional space. So the technology being rolled out is mobility across four dimensions as compared to your traditional three-dimensional combustion-based technology. Now, in terms of that in engineering, we're looking at robotics and AI-controlled fieldcraft systems, and that links back to psionics as well, and chemistry. So you can see how these are all related. So you can no longer just be a siloed subject matter expert, because everything's interconnected. So the whole way we approach this in the education sector has got to shift to meet the demands of industry and rolling out the technology when it's integrated across so many areas of science simultaneously. In terms of lesson plan highlights for this companion document to the white paper, so for lesson planning, physics, for example, is you're going from launch mechanics of rocketry into scalar propulsion modeling. For chemistry, we're going from spectral analysis from atoms to harmonic biosignatures. And Energyscape has done a little bit of work at signatures and biosignatures, and published some documentation on signature analysis of UAP and its application in terms of reverse engineering and understanding what these signatures represent in terms of anomalous phenomena. In terms of biology, so we're looking at neurons and brain waves linked to interface systems. So those lessons are structured around psionics and consciousness control interfaces with the scalar field technology. In terms of Earth and space science, we're looking at anomaly mapping and planetary field dynamics. That's looking at the relationship between the physical dimension and four-dimensional space in terms of energetic field coupling. And then engineering, we're going from circuits to cognitive control overlays. Now that links a lot with biology and chemistry as well, in terms of resonance and psychology, in terms of neural transmission of brain waves into cognitive control overlay systems. So even moving beyond holographic interface control and into actually thought controlled craft. So interdisciplinary curriculum modules reaching across those subjects. So we're looking at study, contrast, explore, and your energetic field. So for study, we're going from IR spectroscopy and harmonics. So we're looking at studying vibrational resonance in biological and UAP signals. Now, Energyscape's lab is actively researching that area and has published on it on our ResearchGate page and technical reports. And for contrast, it's propulsion system comparison. So we're contrasting rocket-based versus inertial and scalar motion in that regard. And in terms of exploration, we're looking at neural interface and psionics. So we're exploring EEGs and the future of mind-machine links. And for field-based analysis, we're looking at energetic field interaction labs, so hands-on demos of electromagnetic fields and vibrational coherence. So there's lesson plan guides in the companion document in those areas as a guide to schools and educators on how to go about implementing this in schools. So there's 4 phases really to this. So phase 1 is teach training. So it's introducing the new concepts around the paradigm shift in science that's upon us now via workshops and online modules. Phase 2 is the pilot programs within embedded STEM programs and existing space science programs. So 4 to 6 week electives to trial bridge lessons to those programs. Phase 3 is industry integration, so site visits, guest mentors and R&D exposure to what's being rolled out in industry at the moment as companies position themselves for all this. And then phase 4 is national alignment, build momentum through documentation, publication and curriculum boards. And I would say that Energyscapes has gone quite a long way into all of this already, We've got a few more documents coming out in this package soon, so we'll end up with 5 or 6 reports published on our website, with the final one linking all the previous reports together into one overarching structure on how to roll this out in the education sector to support industry needs that are emergent and very shortly going to become of immediate need, I would say. So it's a strategic call to action supporting the white paper, so endorsing pilot testing, so validating concepts through real student outcomes, facilitate training, so empowering teachers to lead this shift, policy recognition, so advocating and will advocate emerging science fields and STEM frameworks, so it's embedding it within existing STEM frameworks and space science programs, and then publish and scale accordingly to the capacity and capabilities of schools and their sizes, so showcase results and replicate success nationally. So there's an outline of that in the documents that we've published. So once again, thank you for listening. We have a few more presentations on this whole concept in terms of transforming how we go about doing this to meet the needs of industry by the education sector moving forward, and some more documentation coming out over the next few weeks. So I look forward to sharing that with you through Energyscapes Lab in the very near future and talking about it more again soon.